Good morning, everyone. I would like to welcome you all in the second session of Community Week celebration. So let's begin the session with the Sanskrit Vandana. Good morning, everyone. I would like to welcome you all in the second session of Community Week celebration. So let's begin the session with the Sanskrit Vandana. Good morning, everyone. I would like to welcome you all in the second session of Community Week celebration. So let's begin the session with the Sanskrit Vandana. Good morning, everyone. I would like to welcome you all in the second session of Community Week celebration. So let's begin the session with the Sanskrit Vandana. Good morning, everyone. I would like to welcome you all in the second session of Community Week celebration. So let's begin the session with the Sanskrit Vandana. Good morning, everyone. I would like to welcome you all in the second session of Community Week celebration. So let's begin the session with the Sanskrit Vandana. Good morning, everyone. I would like to welcome you all in the second session of Community Week celebration. So let's begin the session with the Sanskrit Good morning, everyone. I would like to welcome you all in the second session of Community Week celebration. So let's begin the session with the Sanskrit On the behalf of Akhil Bharatiya Vidya Bharati Shiksha Sansthan, I, Geeta Arora, welcome you all in the second day of Community Week celebration. Today we have with us Mr. Nitin Chaube, IT expert and the ATL event coordinator who planned all the activities related.
Hello. Hello Geeta ji, am I audible?
Yes, yes, sir, you are audible.
जी जी सभी को नमस्कार। हम लोग ये कम्युनिटी वीक सेलिब्रेशन के आज द्वितीय दिन के इस सत्र में आप सभी का स्वागत है। सत्र आरंभ करने से पहले कुछ सूचनाएं हैं जिसके बारे में मेरा सभी विद्यालय से आग्रह है कि सभी सूचनाएं ध्यानपूर्वक सुनेंगे और उसके ऊपर अमल करेंगे। सबसे पहले सभी विद्यालयों को ये सूचित किया जाता है कि वो अपना अपना माइक जो है वो म्यूट कर कर ही रखे। जब क्वेश्चन आंसर एंड सेशन होगा तभी आपको माइक अनम्यूट करके अपने क्वेश्चंस जो एक्सपर्ट मेंटर्स हैं हमारे उनसे पूछने हैं और वो फिर आपके क्वेश्चंस का जवाब देंगे। दूसरा, कल के सत्र में जिन्होंने पार्टिसिपेट किया था उन्हें पता होगा कल के एक्सपर्ट मेंटर्स ने हमारे लिए आप लोगों के लिए कुछ टास्क दिए थे। मैं वो टास्क का फिर से एक बार रिपीटेशन आपको बता दूं। कल का हम लोगों का सेशन ऑर्डिनो यूनो और नोड एमसीयू पर था, जिसका टास्क पहला दिया गया था एक्सपर्ट मेंटर द्वारा, टेम्परेचर एंड ह्यूमिडिटी मॉनिटर। जो लोग का नोट डाउन नहीं कर पाए थे वो कृपया नोट डाउन कर ले, विद्यालय और टीचर्स। इसमें आपको गोल था डिस्प्ले रियल टाइम टेम्परेचर एंड ह्यूमिडिटी यूजिंग DST11 सेंसर। इसमें जो कंपोनेंट्स आप यूज कर सकते हैं वो DST11 सेंसर है और Arduino यूनो नोड एमसीयू के साथ साथ। टास्क 2 जो था वो ESP8266 क्विज बजर सिस्टम 2 प्लेयर्स। इसमें आपको बिल्ड अ सिंगल क्विज बजर यूजिंग 2 बटन एंड LED। ये दोनों प्रोजेक्ट्स आपको करने के लिए टास्क दिए गए थे कल के मेंटर द्वारा। ठीक है, अब हम लोग आज के सेशन की तरफ आगे बढ़ेंगे। आज के सेशन के आगे बढ़ने से पहले मैं आज के जो एक्सपर्ट मेंटर हमारे साथ जुड़े हैं अभिनया जी, मैं उनका परिचय देना चाहूँगा। अभिनया जी मास्टर्स इन्होंने किया है, इसमें गोल्ड मेडलिस्ट है। इलेक्ट्रॉनिक्स एंड इलेक्ट्रिकल इंजीनियरिंग से इन्होंने मास्टर्स किया है। अभी ये अपना PhD परस्यू कर रहे हैं। इन्होंने काफ़ी रिसर्च वर्क भी किया हुआ है ऑलरेडी। इनके नाम से पेटेंट्स है। ये अटल इनोवेशन मिशन के चेंज ऑफ मेंटर भी रह चुके हैं। उससे रिगार्डिंग इन्हें बेस्ट चेंज ऑफ मेंटर का अवार्ड भी मिल चुका है। आज हमें अभिनया जी रास्पबेरी पाई से के बारे में मार्गदर्शित करेंगे। मेरा निवेदन है अभिनया जी से वो अपना प्रेजेंटेशन रास्पबेरी पाई के बारे में स्टार्ट करें। जी।
Good morning, everyone. Am I audible?
Yes, ma'am, you are audible.
Okay, thank you. I am Abhinaya Inbamani, all the way from Tamil Nadu. I'm currently residing at Tallahassee, Florida. I'm happy to be here with all of you today. I'm excited to share a session on Raspberry Pi. As Nitin told, I hold a PhD in electrical engineering and I have been working in the field of embedded systems for past 10 years. I'm really looking forward to dive into this topic. I'll share my screen and we will start the session. Okay, so today we are going to explore about something called a Raspberry Pi. So Raspberry Pi is a small, powerful, and a full of magic computer. Okay, so it's a tiny computer that is capable of doing amazing things. Imagine you want to build your own video game or you want to make a robot move or imagine you want to create a weather station. All of this is possible using the small device that fits in your hand. That's how a Raspberry Pi will allow you to do. So today I will be your guide into this fun and creative world of how to explore the Raspberry Pi. So here's a quick agenda of what we are going to do. First, we will see what is Raspberry Pi. We will discover what this magical mini computer really is. Then we will understand why Raspberry Pi, why Pi board is really important. We have Arduino boards and BeagleBone boards in the market, but still why Raspberry Pi is important? Why is it so popular? Why are people all around the world using it in real time? How to use the Raspberry Pi in the laboratories? What are the softwares required and what languages does it use? We will understand to use this Raspberry Pi in a simulator called as Oqui. So Oqui is a beautiful tool which helps us to do a lot of projects. So you can simulate the projects here before taking it into real time. Right. Now let's start with the basics. What is a microcontroller? Whenever we start learning electronics, the first important concept in any electronics is all about embedded systems. So embedded system is where a combination of hardware and a software. There are a lot of embedded systems around us. Okay, so now I am in a room. I have a thermostat present in my room, which adjusts the temperature of my house. That is an excellent example of an embedded systems. You can take the digital watch, or you can take a treadmill, or any kind of smart electronic devices which you are using. Everything, it comes under embedded systems. So inside embedded systems, there are two things present, either a processor or a controller. So a controller is something which has a defined applications to do. Now let's take a washing machine. A washing machine has a limited work to do, right? It can wash, it can rinse. So there are a limited functions which are present in a washing machine. So inside washing machine, you have something called as microcontroller. A microcontroller is a controller which has a limited applications and a specific task. Whereas a processor is something like your laptop. It does a multitasking, right? Now let's take your mobile phone. So your mobile phone, does it comes under a processor or a controller? If you ask me, well, earlier it was a controller having a defined application, but now your mobile phone is having the ability to do a lot of things, right? So we have a processor inside our mobile phone. So all the embedded systems around you has either a processor or a controller. Now comes the question. Is Raspberry Pi a microcontroller? So Raspberry Pi is a tiny, affordable computer which has a processor in it. Okay. So it's not exclusively a controller, rather, it's a computer which will have a processor inside it. So this is the first basics which we should know. What is an embedded systems? Let's discuss some real-time applications of embedded systems. And then when you look into any embedded systems, you should know whether there is a processor inside it or there is a controller inside it. So as I told you, a Raspberry Pi is a tiny, affordable computer. So it's about the size of your palm or a deck of cards, but it works just like a full-sized PC. You can watch videos, you can play games, browse the internet, write the code, and in more advanced level, you can even control the lights, fans, robots, and even the drones. So whether you want to be a scientist, a gamer, or a problem solver, Raspberry Pi is going to be your best friend. how this journey started. So let me tell you a quick story. It all started in the year 2012. So in the year 2012, some clever engineers in the UK, they realized that many kids and students, they didn't know how the computers really worked. They only knew how to use them, but they didn't know how to create a computer. So the Raspberry Pi didn't cost a lot of money. So kids and adults from all over the world could use it to learn and create some fun kind of things. People could just plug into the TV or a screen, and with the help of a keyboard and the mouse, they could explore the world of computers. As the time went on, this Raspberry Pi team made even more better versions of the little computer. So now there are a lot of versions of Raspberry Pi with more advanced power and many new features. This Raspberry Pi is used by the people everywhere. Kids use it to make fun projects, and grown up they started to use this in the robots and the machines that can help people in the real time. So at the end of the day, we are really bothered about making a product in a real time. So that is possible with the help of this Pi board. Next, this Raspberry Pi board cost is also very less. It cost about the same size, same as a pizza, but you could use it to build any websites and games and robots, as I told you. So on the whole, this Raspberry Pi is more than a computer. It's where you can do a lot of creativity in learning, and you can bring a lot of products with the help of Pi board. So the Raspberry Pi is awesome because it teaches you to think instead of using the technology. Here you start to create it. You can become a maker here, and you can build a lot of cool stuff. And the models, if you see, they cost around some $35, so which is great for the students and schools to explore on. Please don't use the annotations. I think somebody using the annotations. Please don't use the annotations, okay? Okay, I kindly request the students not to use the annotations. Please don't annotate. Okay. Now let's move on into the parts of Raspberry Pi. So there are a lot of components. Asha, there's a student named Asha here. Please don't annotate. Okay. So now let's look into the parts of Raspberry Pi board. There are a lot of important components in the Raspberry Pi, but we will discuss the most important ones now. The first one is all about USB ports. So with the help of USB ports, you will be able to plug into the keyboard, mouse, and to any USB drive. HDMI ports. So with the help of HDMI port, you will be able to connect to a TV or a monitor. So you can see what the Pi is exactly doing. GPIO pins. So as the name holds, GP represents general purpose input and output. G for general, P for purpose, I for input, O for output. So general purpose input and output pins. These pins are like the magical pins that let you collect the lights or motors, buzzers, any input or output peripherals you can connect to these pins. Micro SD slot. So this is a slot where the Raspberry Pi holds the operating system. It means this is where the Pi keeps its memory and brain. It's like the hard drive. Power supply. So this gives the life to your Raspberry Pi. It's usually done with a phone charger. So this is like the life to your Raspberry Pi, if I can tell you in a easy way. Okay, I think the kids are annotating a lot. Geeta ma'am, can you please check to it?
Yes, ma'am.
You can disable their
गीता जी माना कीजिए वो बच्चे और कुछ कर रहे हैं
I'm sorry, I
स्क्रीन
don't understand Hindi. Can you please tell it in English, please?
आई रिक्वेस्टिंग गीता मैम टू
Ma'am, kindly wait. I'm changing the setting
Okay,
and you can continue, ma'am.
okay. Because I'm able to see there are a lot of scribblings over here. I can reshare my screen again. Might be. Okay. Right. Please don't annotate, dears. Okay. Now let's move on to the next topic. What are the types of Pi boards? So you can see just like the phones which you have the different models. Some are big, some are mini. Raspberry Pi is also having a lot of versions. So Raspberry Pi 4. Raspberry Pi 4, if you see, this is the most powerful version and it can even run a full desktop. Raspberry Pi Zero is one version, so it's going to be a super tiny one that can do some smaller projects. Raspberry Pi, Raspberry Pi Pico is not a full computer as such, but this is a smaller version of a Raspberry Pi. So it's like a microcontroller which can control the electronics, and it is perfect for many of the smaller projects like a traffic light controller, or when you want to interface any of the sensors to the boards, that can be done very easily with the Raspberry Pi Pico board. So today I'll be teaching you with this Pico board. Okay. You can do a lot of smaller projects before deploying the products into real time. You can experiment this Pico board in the OQ simulator. Okay, so we learned what is the meaning of embedded system and why Raspberry Pi is required. Now, why as a student I should know coding? So coding is very important when you want to explore any electronics, whether you start with an Arduino or you're going to move on to a Raspberry Pi board. Coding is very much necessary. Why should I learn coding? So imagine you are the boss, okay? And Raspberry Pi is your assistant. So you need to give a clear instructions to it step by step. It's after all a device, right? So once you give instructions only, it is having the ability to work. So that's why the coding is very important. So now imagine you are telling, okay, for example, you can write, turn on the light, wait for 2 seconds, turn off the light. So as a human being, when you give these instructions to me, I'm able to understand. But your Raspberry Pi board will not understand, right? So coding is necessary when you want to make your device understand the language. Now I'm speaking in English and you are able to understand English. So That's the reason why both of us are able to converse today. So that's how you need to work on the electronics as well. Okay. Now, how to converse with my Raspberry Pi? I understood how to work with Raspberry Pi. I need to blink some LEDs, play some sounds, take some pictures, work with some sensors, make a motor to run, all kind of peripherals I just need to explore. This is the scenario. So how to do it? What is the language which I should use? Right. So there are a lot of languages present here. Python, Scratch, C and C++, Java, JavaScript, Ruby, Bash. So any of these programming languages you can use. Just like the humans speak different languages, Tamil, English, Hindi, the Raspberry Pi also can understand different programming languages. The most popular ones, if you see, is all about Scratch. So if you see in Scratch, it is great for the beginners. You can drag the colorful blocks like a puzzle and you can work on. Python is again very easy and powerful, and it is going to have some real words like print and while. So by looking into that English word, you can understand what that command means. C and C++ or JavaScript. So this is a little bit advanced, but it is good when you are going to deal with the higher end projects. You need not note down all these things because I will be sharing this presentation with ma'am once the class gets over. But I just want you to listen. Okay. Please don't annotate. Please don't mute me, right? I find somebody is muting me as well. Don't do that. Okay. So we have these many languages present and you can use any language. So in yesterday's session, I hope all of you learned how to work with Arduino boards. So even you can use those Arduino programming language and dump in the Raspberry Pi board. That's also possible. So today I'll teach you how we can do that. Okay. So we saw what is an embedded system, what is all about the Pi board, and why you require a coding. Now comes a next interesting word called OS. OS means it's called operating system. So operating system, all the embedded devices has an operating system. A Raspberry Pi needs an operating system just like your phone has an Android or an iOS. Okay. The most common operating system for the Raspberry Pi, we call it as Raspberry Pi OS. Earlier, we used to call that as Raspbian. To be very simple or to make you understand, operating system is like a manager. Okay. That manager will help you to open the app, run the program, let you type, click and play. Okay. So you need not dump this operating system into the Pi board because it already comes with the tools to code in Python and Scratch. So you don't need to install that much, but still you should be aware about like what is an operating system. So earlier we call it as an Raspbian and now they have changed the name to Raspbian Pi OS. So as I told you, it's like a manager, okay? You can open the app, you can run any programs, you can click and play, you can do a lot of stuff with the help of the Raspberry Pi. Okay. As I told you, there are a lot of versions present in the Raspberry Pi, like version 0, 4, and Pico board. Today, we are going to use a simulator called as OAKV. I'll teach you how to use this Raspberry Pico board. Okay, don't get panic, dears. All these are very simple. If you start to learn one controller, all the controllers you will learn very easily. So I'll just give you a clue of how this is working. GP means it is called general purpose. Means there you can connect any peripheral. When I say peripheral, you can connect an LED, you can connect an LCD, a buzzer. So all the devices which you have apart from the controller is called a peripheral. So in this GPO, I mean GP0, GP1, GP2, 3, 4, 5, 6, 7, you can connect LEDs or you can connect a resistor. Okay, that's the meaning of GP. GP means general purpose. GND. GND stands for ground. So whenever you're working on any electronic device, two things are necessary. Number one, supply voltage. Okay, we call that as VCC. You need to give a supply voltage for it and then you need to ground it. So if you don't give the proper supply voltage and if you are not grounding it properly, what will happen? That particular electronic device will blast and it will not work. So when you are working in real time, you see that you are giving this VCC and ground correctly. Okay. So now I'll show you in Walkway Simulator how to use this Pico board. Right. So first we will learn. First, I will explain how this coding works, right? So this is the Pico board which I told you. I will show you in a simulator how to bring these tools and how to type this code. Okay. Just like your Arduino programming, you can program in Pico board as well. So I initially thought of teaching you for programming this Pico board with the help of Python. But when I checked to your yesterday's class, I understood there was a faculty who taught you about this setup and loop and all these kind of stuff. So you can dump these code itself directly into Picoboard and still it will work. Okay. Now let's start with void setup. So we are aware that this is a special function, void setup. So what happens here? So you have to think of it as a part of program that prepares everything before the main action happens. So it's going to happen only once, okay? So when you first turn on or reset your Raspberry Pi, this, whatever you have kept inside the void setup will run. Okay, so you need to imagine that this is going to happen only once. Then you have a curly bracket. So this curly bracket, it means you're going to start the list of things that the setup function has to do. So whenever you open a curly bracket, you are supposed to close it. Okay, then only your Pi board will understand. So Pi board is after all a device. So you need to give the instructions correctly, then only it will work. So once you open the bracket, don't forget to close the bracket. Next, serial dot begin. As a human being, I am aware that this is a lowercase letter and this is the uppercase letter. But your computer will not know. So instead of giving a uppercase yes, if you give a lowercase yes, it will not understand. Okay, this is called case sensitive. So case sensitive means wherever you need to use uppercase only should be used. So in yesterday's class, that mom would have taught you about pin mode. So PINMODE. So here you can witness M should be in capital letter only. Instead of a capital letter, if you write pin mode, it will not work. Because all these controllers work according to your instructions. So if you write pin mode all in lowercase, it will not understand. Likewise, your S should be in capital letter. Okay. Serial dot begin 11,000. So you can see here 115,200. So you have a big number here. What is all about this? Let's disclose that now. Fine. So first of all, you have something called serial dot begin. What is this? So this line, it tells the Pico or the Pi board to start talking to a computer or another device using a special tool called serial communication. So serial communication is where the Pi board is talking to a computer or to another device. Okay. So serial 1. So serial 1 is the first connection for the serial communication. So you can imagine this like a phone line. Okay. You can imagine this like a phone line between the Raspberry Pi and another device. And this number 115200 is nothing but it is the speed at which they will talk to each other. So in this case, it is going to be 1,15,200 bits per second, which we cannot even imagine, right? So this is going to be bits per second. So serial dot begin means you have to imagine this like a phone line, okay? So the phone got connected and now I need to know at what speed this particular information is transmitted. So in this case, it is 1,15,200 bits per second. Imagine it is like setting the speed limit on the road, okay? So in a road, you have a speed limit, like you have to go to 35 miles per hour, like that. Like that, you have this particular number which decides the speed. Okay, so here it is going to be bits per second. Next, you have serial 1 dot println. Hello, Raspberry Pi Pico. So whenever you are completing any instruction, you are supposed to end with a semicolon. So when you end with a semicolon, your board will understand that that line is getting over. I need to go to the next line. Now, as a human being, how do you write an essay? You keep a full stop, right? So when you put a full stop, you understand that I need to go to the next line. Similarly, your Pi board understands only the semicolon. Now we will understand what is the serial dot println. The Pico will send a message over that phone line. The message is going to be hello Raspberry Pi Pico. So this println part means that so once the message is sent, it will be moving on to the next line. It is just like pressing the enter on your keyboard. So you will see this message on the screen in your serial monitor. Okay, so this is all about the void setup function. Next comes void loop. So this part is called loop. What is the meaning of loop? It is going to run over and over again. Whatever you are putting inside this particular void loop, it is going to run over and over again after the setup is being done. So this is just like a machine that keeps running forever. Every time the program finishes something inside the loop, it will start again from the beginning. Okay. Next, delay 1. So what's the meaning of delay 1? 1 represents 1 millisecond. So you can remember this like, this line is like telling the Pi board, take a very, very short snap. Okay. After the lunch, we all like to sleep for some time, right? After having a heavy lunch, we all like to sleep for some time, right? Yes or no? Likewise, this line is just like telling to the Pi board, take a very short nap. So it's going to pause for 1 millisecond, okay? Which is going to be really very, very less, but still, our main aim of using the embedded system is you need to execute everything in milliseconds. Correct. Imagine I am running the washing machine. I give start, okay? And once I give start, immediately the machine should work. Let's imagine the machine is working after 1 hour. Will you like that? No, right? So if I give start, it should work immediately. That's how the embedded systems work is required. So here you can see I'm expecting a delay of only 1 millisecond. So as I told you, once you open the bracket, you are supposed to close the bracket as well. Okay, dears. So this is how you need to write the basic program of using the Pico board. Now I will show you how to use the Pico board with the LED and a resistor. Let me go to the Oakview platform and show it to you so that no, you will start to work on this. Let me give me a minute, yes. I'll go to the Oakview platform. Okay. I hope all of you can see this platform. This is called, this Oakwee platform is just similar to the Tinkercad platform. I hope you are aware about the Tinkercad platform. So Arduino, with the help of Arduino boards or any microbit controllers, you can use the Tinkercad platform. Oakwee is again an excellent tool when you want to do projects on IoT or any ESP32 or STM32. STM32 is a beautiful controller. So in earlier in 2015, when I started to work on all the controller boards, okay, I learned from the university called Sastra at Tanjavur. So that's a very good university which makes you to work on lot of boards. At that time, I was not familiar about this STM32. I have worked on BeagleBone and other kind of boards. But recently, in 3 years back, I started to do some projects on STM32, and then I found the beauty of that particular controller. You cannot even imagine the, output and the operating system which is present inside the STM32. So if you are really interested in electronics, start to explore on Arduino first. Try to do some minimal of 10 to 15 experiments in Arduino. Once you get used with the board, okay, and with the controller, once you understand the basics of coding and the operating system, you can work on any controller boards. So start with Arduino, then go with Pico, later proceed to STM32. Finally, you can touch upon this ESP32. So this is the order in which you have to start working on the boards if you are really interested to proceed with the electronics. Right. So oakwee.com is the platform. Might be I can share it in the chat box. So this is a beautiful tool which helps you to simulate all things before trying it in real time. Simulations are mandatory many a times because if you give the connections wrongly for the ultrasonic sensor, it will get burnt in a minute. Okay, so you have to be careful about which is the VCC pin, which is the ground pin, and which is the signal pin. So it is better to do it in the simulation platform and then you can work on the hardware. Okay, so in order to do this, first of all, you just need to go and give sign in here. Okay, and all these are recorded, so you need not worry. You need not follow the instruction. Just listen. It is sufficient. Once you go to your house, you can check to this video and try to replicate what I have done. So you can log into your mail first. Okay, and then I'm just giving sign in. Continue with Google. So you can use any of the mail IDs which you have. And all these are free platforms. We are not paying anything for this. Okay. It's a free open source platform. Right. So now I have opened the tool. You can start with my projects here. In my projects, whatever projects you have done, that will be visible. You can start with new project. In the new project, there are a lot of options here. As I told you, you can either use ESP32, STM32, Pico board, Arduino, or blank. Now I'll teach you with Pico. Later in your house, you can just sit and experiment all these things. Okay, all these are very easy, dears. And even if you give wrong connections, still it is going to show you the errors, which helps you to rectify before making it as a product. So I'm choosing Pico here. So you have two options, Raspberry Pi Pico, Raspberry Pi Pico W. This is with Wi-Fi and here you don't have Wi-Fi. Normal Pico board, there is no Wi-Fi present. In Raspberry Pi Pico W, you have a Wi-Fi present. So if you want to do any IoT projects, you can work on this. I'm going to teach you with Raspberry Pi Pico. Okay, so let me click that first. So in Raspberry Pi Pico, as I told you, Pico board is just like human being which can understand a lot of languages. Okay. So you can start with Arduino, MicroPython, CircuitPython. Any programming language you can use. So I'm sure that all of you like Arduino very much, right? Because that's user friendly and the coding is also very easy in Arduino. So let's start with Arduino. Okay. So I'm clicking Arduino. So once you click Arduino here, inbuilt Raspberry code will open. Raspberry Pi Pico board will be opened here. You can see the Pico board. Okay. You can just use your mouse in order to scroll in. You need not remember all the pins. The Oakway platform has made it very easier. You can just go and place it near the pin. Okay. It will tell you what each and every pin represents. So you can see here GP5. GP5 means general purpose 5. G and D ground. GP6 general purpose 6. Okay, so there are a lot of pins present. Around 40 pins are present in the Pico board. So when you bring the Pico board onto your screen, this is the default code which will come. I haven't typed this. Okay, it's a default code. See, in the beginner template, I'm just choosing Arduino. The default code comes. Now, I'll tell you how to run this code. Okay, so this is the code which I explained to you now. Void setup serial.begin 115200. This is the baud rate. Baud rate means bits per second. To explain in a layman term, imagine this like a phone line. Okay. First, you established a phone line. Then you are going to decide what is the speed at which that message has to be traveled in that phone line. Then you are deciding what is the message to be transferred. So this is the message which I have transferred. Hello, Raspberry Pi Pico. Okay. And I'm going to give 1 millisecond delay. So here you can see start the simulation. This is nothing but adding new parts. Whenever you want to add some new components, you can add here. You have a joysticks, IR receiver, potentiometers. I hope all of you likes to work on sensors, right? So these are some of the sensors which are present inbuilt in the Oakway. I'll be teaching you with one sensor today. Might be, we can try motion sensor. Okay, motion sensor and some alarm or some LED we can try today. Right. So with this, these are the two important things which you should remember here. Start the simulation, add the new part. So now what am I going to do? I'm just going to start the simulation. So once you start the simulation, you will be able to visualize the output here. So you can see here, I got the code called Hello Raspberry Pi Pico. Okay. So this is how I need to start working with the Oakway. Now let's go to the second project. Let me connect an LED here and make the LED blink. Okay. Let's see how to do it. For that, you can go here and give add new part LED. I'm zooming this for your reference. Okay. So first of all, I'm going to just blink an LED. Okay. So let me take an LED. An LED will have two different ends. One is an anode, another one is a cathode. The full form of LED is light emitting diode. Okay, di means two. So it is having two different ends, anode and a cathode. That is why we call this as light emitting diode. So you cannot connect an LED just like that to the pi board. So you need a resistor here in order to control the flow of current. So the main purpose of resistor is to oppose the flow of current. Okay. So now let us imagine your Raspberry Pi is having a 5 volt. If you give 5 volt directly to the LED, what happens? The LED will blow off. So you need to give always a resistor, and the resistor value should be 220 ohm. So now the LED is having two different ends. As I told you, anode and a cathode. So anode, I'm connecting to the LED. Okay. LED is a passive component. The meaning of passive component is it will not have a positive and a negative end. A LED will not have a positive and a negative end. But your resistor will not have a positive and a negative end. So we call this particular resistor as a passive component. Any electronic device which does not have a positive and a negative end is called as a passive component. Okay, I will zoom this, dears. Okay, now what we are going to do is, let me connect resistor to pin number 2. So you can see that pin 2 is nothing but GP1. Can you see here? GP1. So pin 2 is nothing but GP1. So what is pin 1? GP0. So if you are connecting to pin 2, you should give in the code GP1. Anode is connected to the resistor. And then you have the cathode. Cathode should be grounded. Okay. So I'm going to ground the cathode. That's all. Okay. So see how I have given the connection, dears. I have an LED. Okay. I'm going to do it again for you. So I'm going to take an LED here. Then I'm going to take a resistor. Okay. As I told you, the resistor value should be 220 ohm. So I'm connecting one end of the resistor to the anode and the other end of the resistor I'm connecting to GP1. Cathode, I'm going to ground it. That's all. So with this, connections are over. Now it's time to code. So as a human being, I know that LED is an output device, but your computer or your Pi board doesn't know, right? So I need to code it accordingly. Let's see how to code it. I'll type step by step and make you understand. The first one, define. So define is a macro which we will be using in order to tell the Pi board, see, I'm going to use an LED. I'm going to use a red LED which is connected to pin 1. So define RED1. So the meaning of this particular line is you're telling the Pi board, see, I'm going to use a red LED and that red LED is connected to pin number 1. Imagine you are using GP0. Then what you have to do? You should write hash defined red 0. Okay. So if you are using 0th pin, you should write hash defined red 0. I'm using the second pin, which is GP1. That's the reason why I'm writing hash defined red 1. After this, what I should do? I should write the void setup. Inside the void setup, I should declare which pins are input and which pins are output. So here I'm using only one LED, that's a red LED and it is an output device. So I'm going to give pin mode red comma output. So with this, my void setup is over. Next, I need to go to void loop. So as I told you, void loop is something which is going to run forever. Okay, unless you stop the instruction, this particular loop will run. So let's start. Digital write red comma low. So what is the meaning of digital write? There are two type of signal, dear students. One is an analog signal, another one is a digital signal. Digital means on or off. Analog means range of signals. Okay. Now let us imagine I have 0 to 5 volt. Either 0 or 5 volt. This is called digital. When I say analog, it is like 0 volt, 1 volt, 2 volt, 3 volt. So you have a range of signals, it is analog. So here what you are doing, I am either turning on the LED or turning off the LED. So let me turn on the LED first. Make it as high. So digital write red comma high. What is the meaning of high? High means LED on. So now guess. For turning off the LED, what should I write? I should write digital write red comma low. End with a semicolon. So when you end with a semicolon, it means that you have completed that line and you're going to the next line. So what is the meaning of your 10th line? LED is off. So now you see how beautifully we have instructed the pi board. See pi, I am going to use an LED. That LED is an output device. That's the first instruction. What is my second instruction? Come on pi board, I'm going to turn on the LED and turn off the LED. So to turn on, I will write red comma high, and to turn off, I'm going to write red comma low. You can see that red is present in black color because all these are variables. So variable in sense, instead of writing red, even I can write Abhinaya. Okay. Or even I can write Vidya or Nathan, whatever it is. These are variables. Means your system takes everything as a variable. So whatever name you want, you can give over here. Okay. That's why it is in black color. Whereas when you look into the other commands, it is in different colors like your blue, red, and some green. All these are instructions which is understood by your computer. Okay, so this is a variable. Instead of capital letter M, if I use a small letter M, what happens? You can see that it is in black color. So your instruction should not be in black color. In that way, you can debug your code. You can understand, oh my God, it's not changing in color. Means I have made some mistake in the fourth line. Then you can find it out and then give capital letter or uppercase M. Okay, so all your instructions should be in these colors. It should not be in a black color. In that way, you can learn how to debug your codes. Okay, now as I told you in the 9th line, my LED is on. So for how much time should I on? That's the next question which your pi board will ask. So your pi board, what and all instructions you have given? First you told, come on, make an LED as an output. Then you told on the LED. Then you told off the LED. These instructions you told the pi board. Now the pi board will ask you, for how much time should I turn on? For how much time should I turn off? You didn't give me that instruction. So for that we have a command called delay. Delay 1000. So what is the meaning of 1000 years? It is 1000 millisecond. Your board understands only millisecond, which is very less. Okay, it's not even second. If I say 1 second, it's very small, but milliseconds are even more small. It's 10 power minus 3. Okay, so I have to turn on the LED for 1000 millisecond. Similarly, I want to turn off the LED for 1000 millisecond. Okay, so this is how you need to write the code for turning on and off the LED with a millisecond delay. I hope this is clear. Only when you understand the basic of one LED, you can replicate the same with 3 different LEDs. Okay, so I'll show you how to do the same with 3 different LEDs. Let's run the simulation. Sometimes it takes 1 or 2 minutes in order to compile the project. You can save the project then and there so that you're not losing it. And then you can start the simulation. You can see LED is on and LED is getting turned off. So this is for one LED. Now you can replicate the same with 3 different LEDs. That will give you a traffic light control. You can use an yellow LED, you can use a green LED and bring some variations in the code, which we will be doing as a second work now. Okay, so I hope you understood how to work with a single LED. Now let's try with 3 different LEDs. Okay, I will explain very slowly. So those who didn't understand this logic, at least try to listen now, dears. Okay, see, now I'm going to do a small project of traffic light control. Okay, so in traffic light, how many colors you're having? You're having 3 colors, red, yellow, and green. So now let's define those. Hash define yellow 2. Hash define green 3. So what I have done here, I'm using 3 different LEDs and the 3 different LEDs are red, yellow and green. I have connected red to pin number 1. I have connected yellow to pin number 2. Green to pin number 3. Okay dears, so first of all, I have defined it. Next, as I told you, in the void setup, you need to declare which of these LEDs are input and output. So we know that LED is an output peripheral. Let us imagine you are having a sensor. So sensor is an input device. Okay. If you have a switch, if you plan to use a switch here, you should define inside the void setup as switch comma input. So now you're going to use only the LEDs and all the LEDs are the output peripherals. So you can start to declare here pin mode, yellow comma output. As I told you, pi boards are case sensitive. It doesn't understand the difference between the lowercase and the uppercase letters. So be careful when you are typing the instruction. Pin mode, green comma output. So inside the void setup, I have declared all the LEDs as the input and output. Okay. Now let's go inside the void loop. So inside void loop, what am I going to do is, first of all, I want to turn on a red LED. Okay. I want to turn on the red LED. Yellow and green should be off. This is my first instruction. So let's try to do it. Digital write red comma high. So in digital write red comma high, my red LED will be on. As I told, now when the red color is on, yellow and green should be in off condition. So digital write yellow comma low. So what happens here, dears? Your yellow LED is off. Next, digital write green comma low. So what happened here? My green LED is again in the off condition. So with this, my first condition is over. My red color is on, yellow and green is in the off condition. Next, what I should do in the traffic light, first red will be on, then which light will be on, yellow will be on, then your green will be on, right? So this is how the traffic light works. And that's how we are going to replicate it now. Let's give some more a delay, like some 5 milliseconds, like that, okay? So with this, my first condition is over. My turning on the red LED and yellow and the green is in the off condition. Let's start with the second one. Turn on yellow LED. Turn off my red and the green one. Okay. So I'm just going to copy this, paste it here. So red should be low, yellow should be high, and green should be in low. So this is how my second condition is done. Now let's go with the third condition. Turn on green LED, turn off red and yellow. So again, you can copy this, paste it here. So as I have mentioned here, your green value alone should be in high. Red and yellow should be low. That's all. So with this, the coding is over. Now we are going to look into the hardware connections. So earlier we gave connection for one LED. Now we are going to replicate the same with the two different LEDs. Okay. So let's start to give the connection. I'm going to take the yellow LED now. Then I'm going to take a green LED. So for each and every resistor, we are supposed to use, for each and every LEDs, we are supposed to use a resistor. Please don't annotate here. Again, I'm able to see some kid is annotating. Please don't do that. So for the green LED, again, I'm going to take a resistor. The resistance value is going to be 220 ohm. Now it's important to give the connections. Look to the coding part, dears. You can see that my red is connected to GP1. How about the yellow? Yellow is connected to second one, GP2. So go and search where you have the GP2. So this is GP1, ground 1. So here you have the GP2. So I need to connect to GP2. Okay. Imagine you are connecting it to GP0. So accordingly, you should change the code. Okay. And one end of the anode, I'm connecting it to the resistor. So anode should be connected to the resistor and the resistor other end should be connected to the any of the general purpose pin of the Raspberry Pi board. Without the resistor, the LED will blow off. So you should use the resistor. Okay. Then you have the cathode. Cathode needs to be grounded. So now you can go and search for the ground here. GP4, GP5, ground. Okay. So you can just ground it. Similarly, now we need to work on the green LED. So green LED is connected to the third pin. Let's see where you have GP3. So here you have GP3. So take the resistor other end and connect to the GP3. As I mentioned, GP is nothing but general purpose. Your resistor is a passive component, means it does not have a positive and a negative end. And now you can take the cathode part and look for the ground. Okay, so with this, the connections are over. So whenever you are getting errors like this, don't get panic. Just close it, go and check what are the errors. Okay, so you can see that here in the define, I have given 3E. Okay, but when I called inside the program, I called it correctly. So this is the mistake which I made. So go and change it and then give start the simulation. So first your red LED will be on. After some time, yellow. And then your green will be on. Okay, so this you have kept it inside the void loop. So what is the meaning of void loop, dears? You're going to run it forever. Means till you stop the simulation, this is going to replicate. Your red will be on, followed by yellow, followed by green. So this is going to happen and it's going to run forever till you stop the simulation. That's the importance of void loop, and that's a speciality of using the controller boards. Okay, so in a normal electronics where you don't have the controller boards, you can run it once. You can run the LEDs once, but when you want to run it forever, controller boards are must. That's the beauty of using the embedded systems in real time. Okay, fine. So this is the second important project what I wanted to teach you. Let's go with the third one. Might be we will take some sensors now and explore. Okay. Always save your project then and there. You can just go back and try with a newer project. Okay. So now let's try one project with a sensor, PIR sensor might be. Let's take a PIR sensor. So can you all understand till this? Any one or two messages in the chat box? Are you finding any difficulty? Shall we go to the sensors or do you want me to repeat the LED project again? Any one or two projects, please? I mean, in any one or two messages in the chat box, can you give theirs? Are you comfortable with LED? Shall we go to the sensors? Yes, okay. Please don't annotate yours. Yes, okay. Thank you, dears. Thank you for the reply. No problem. Whatever version of Raspberry Pi you are having, look to the pins correctly and then give the connections. That's all. Okay, it will work. Many of the Raspberry Pi boards are supporting the Arduino template, so it will work. Okay, dears. Now, let's take a PIR sensor, okay? It's going to detect whether the motion is there or not, okay? If there is any human movement, it will tell you movement is detected, else it will tell you no movement is detected. If the movement is detected, we will keep some LED and we will blink that LED, else we will turn off the LED. Instead of LED, you can also connect an alarm over there, okay? Let's take an LED here. See, LEDs or alarms are just an output peripheral. If you know how to work on one peripheral, other peripherals are just as simple. Okay, it's not that difficult. So if you want to connect an alarm here, simply you can, an alarm in sense, I'm telling a buzzer. If you want to connect a buzzer here, a buzzer will just have a positive and a negative end. Okay, so you can simply connect the positive end to the supply voltage and the negative to the ground. You will hear the buzzer. So either use a buzzer or an LED as an output peripheral just to visualize the output. Okay. Now, let's start to give the connections first. So as I told you, we need to take up 220 ohms. LED is a passive component. I'm repeatedly telling these stuff because these are very important here. Okay. Now you have the other end of the resistor. The other end of the resistor, you can connect to any of the pins. You see that you are giving the number correctly in your code. Okay. let me give to might be GP5. Okay. You see that you are giving GP5 correctly in the code. Cathode, let me ground it. So with this, LED part is over. Now it's time to look into the sensor part. So in the sensor, you have three different end tiers. You can see VCC, out, and ground. These concepts you need not remember. Just go near that pin. Oakvi will tell you what it represents. Okay? VCC, out, ground. So ground, G and D for ground. You can give it to any of the grounds of Oakvi. Okay? I mean to the Raspberry Pi. So you can witness there is a ground connection here. Ground 7. And the positive is being connected to V bus. Okay. Let me move on to the already termed code that will give you an easier way to showcase. Right. So you can see here, I have the positive end. The positive is connected to V bus. Okay. Then I have the negative pin. The negative pin I have given to ground. D is nothing but it is the output pin. So the output is being connected to GP15. Okay, so this is how the connections are given. Either you want, you can use an alarm here, or as I told you, you can take up an LED. It will still work. Okay, let's go for an LED here so that you understand it better. That's all. You can use anything, dears. Okay, so with this, the hardware connections are over. Now let's go to the coding part. In the coding part, I'm going to explain step by step. Very simple. Just in another 5 minutes, we are going to complete this. Okay, it's very simple. In void setup. In void setup, what are we going to do, dears? I'm going to tell my Pi board which is the input and which is the output. So let me use pin mode. I'm going to have the 15th pin here. So can you tell me whether the 15th pin is the input or output? Can you tell me in the chat box, dears? Look to this hardware and tell me, is the 15th pin input or an output device? Okay, some of you are telling output. Is sensor an input or an output device, dears? What is a sensor first? What will a sensor do? Okay, fine. Very good. Right. I'm able to see some answers with input and some answers with output. Right. Now, listen, dears. What will a sensor do generally? A sensor is something which is going to sense the environment around you. Okay. Let's take your mobile phone. In your mobile phone, you have more than 100 types of sensors present. Okay. So when you are picking up the call, the light gets dimmed automatically. That's because there is a sensor present inside your mobile phone. So you have more than 100 types of sensors present inside your mobile phone, which you cannot even imagine. So sensors are purely an input device. Okay. Anything which you can visualize is called an output device. Your LED is an output. Your alarm is an output. But sensor is an input device. So you can see here, I am connecting the sensor to the 15th pin. So pin mode 15, input. Please don't annotate, dears. Next, pin mode 5. So 5 is nothing but it is the pin where I have connected my LED. So LED is an output device. So I have to write pin mode 5, output. So inside the void setup, what and all I have done, dears? I have just declared which is the input and which is the output. So if you want the hello statement to be printed, you can give a baud rate here and print it. So serial 1 dot begin 115200. So if you want, you can give these statements and print the hello. Else, if you feel it is confusing, we can just stop with input and output. Okay. Next, void loop. So inside the void loop, what are we going to do here? So first of all, as I told you, you are going to read the sensor value.
Abhinaya ma'am,
Yes. Yes,
sorry for
ma'am.
interruption. Ma'am, you can change the setting, go to more and change the setting, delete setting from participants. I think from your side, you can change the setting for the participants
Okay. Okay, ma'am.
because
I'll
you are using annotation. No?
yes. Okay. Disable annotation for
Yes,
others.
yes.
Right. Yes, ma'am. Thank you. Okay. So now we will go inside the void loop, dears. So in the void loop, first of all, what are we going to do? You're going to read the sensor value. So to read the sensor value, you have a command called digital read. Okay. Earlier we wrote digital write. When you write digital write, it's like turning on and turning off the LED. So digital read means you're going to read the PI sensor value. Okay. So let me take int PIR is equal to digital read 15. So what is the meaning of this particular 13th line? Whatever you have connected to the 15th pin, I'm just going to read it and store in something called PIR. So PIR is a variable. So in the last two projects, I told you what is a variable. So variable is something, it is just like assigning a name to your device. Your PyBoard doesn't know that this is an LED, doesn't know this is a sensor. So you're just giving a name for it. Okay, you can either keep PIR or Abhinaya or anything, secondary, Adarsh, Vidya, anything, any name you can keep over there. Okay, dears? So int PIR is equal to digital read 15. So what happens here? You're reading the PI sensor value. Now, let me check whether that PIR value is high. So if the PIR value is equal to high, then what I should do? I should print serial 1 dot println. I should print that some movement is deducted. Also, I should turn on my LED, right? So I have to write digital write 5, high. So can anybody tell me what is the meaning of 17th line? Can you post in the comment, dears? What is the meaning of 17th line? LED will glow. Very good. Excellent. I'm very happy to see the comments. Very good, dears. Very good. Excellent. So your red LED will glow. Digital write 5, high. After that, if you want, you can give a delay here. So delay 500. So I'm just giving a delay. This is random. You can just give it to your own wish. So if your PIR value is high, this should happen. Else what I should do? I should print that there is no movement deducted. So serial 1 dot println, no movement detected. And then I have to write digital write 5 comma low. So if there is no movement detected, my LED should not glow. Okay. Don't forget to give a delay. If you're not giving a delay, what happens is that LED will turn on and turn off in no time and you will not be able to guess it. That's the problem, dears. That's why they always ask you to give a delay. Okay. So you can see in void loop, I have opened the braces here. I am supposed to close it. Similarly, if I open a bracket here, I'm supposed to close it. So whenever you open a bracket, you are supposed to close it. If you don't close it, it will throw you an error, right? So this is how we need to write the code for the PIR sensor with an LED. Now let's try to run the simulation. So you can see here, if I give simulate motion, okay. Now I can visualize the output in the serial monitor. I have given serial.println movement detected, but we have not given a serial begin option here. It's getting hanged. Please give me a minute, yes. Okay. So I should use a serial.begin here and a serial println statement in order to visualize the output in the serial monitor. So serial1.begin. Did you see how we are debugging things? So once you run the output, you are not able to visualize it in the serial monitor because I have not told my system about how many bits I should transmit per second. Give me a minute. It's getting hanged. Okay. 1 minute, dears. Let me run the code and show it for you. I'll just connect the buzzer. Okay, so once you start the simulation, okay, you will be getting like this. Like you can see, simulate the simulation. Okay, you can see simulate motion. So when you give simulate motion, what happens is it will understand that there is some movement happening. So movement detected, okay? And if you stop this, it's like no movement is detected. Okay. So here I have replaced with an alarm. You can either keep an alarm or you can keep an LED as I told you already. Sometimes the OQ gets hanged. Be patient for a while and try to save the project and then reload the page and then run it. In Tinkercad, if you see, this kind of hanging will not happen. But you don't have the Raspberry Pi in Tinkercad. And in this particular OQ, as we are using the Wi-Fi connections and the Raspbian OS is running inbuilt in the Pi board, this type of hanging will happen at times. Now you can see the project what I showed you with LED got hanged. So that's the reason why I'm showing you the project which I saved it already. Okay, so sometimes this OP gets hanged, but still you can use it for developing your prototype before taking this into a real-time product. Okay, so you can see here I'm clicking on the sensor and giving simulate motion. So when you give simulate motion, you can see movement detected. And when you click the PI sensor again, it will tell you no movement detected, right? So this is how you need to work on the WorkV platform. So I have taught you 4 different projects. So first we saw how to run the normal Hello World program in the serial monitor. Then we saw how to turn on one LED. Then we saw how to turn on 3 different LEDs, just like the traffic light control. Then we learned how to use the PIR sensor and with an LED or an alarm as an output. I will be sharing this document with you, so you need not worry. You can copy this code, paste it in the workbee and try to run it. Okay. So these are the 2 projects which I would like to share with you. You can try it and let me know if you're finding any difficulties. The first one, Arduino code for controlling a passive buzzer with Raspberry Pi Pico in Oakview. So use just a normal buzzer here. Okay. Instead of LED, use a buzzer in an Oakview platform. So just go to this 15th slide. You can see I have used an LED here, right dears? So instead of LED, you are simply going to put a buzzer here. There is no changes in the code. In the code, you are just going to define with alarm, okay? Or with a buzzer. That's the first project. The second project which I wanted you to do is button controlled LED with the Raspberry Pi. So use an LED and a button. So once you press the button, the LED should glow. This is just like the sensor project. So if you press some movement in the PIR sensor or if you get a movement in the PIR sensor, what happens? The LED or the alarm is working. Just like that, if you click the button, your LED should glow. So that's the second work. In the first work, try to bring a buzzer dears. In the second work, try to use a button along with an LED. A button or any slide switches, anything is fine. Okay, so some of you have asked, what is 115200? So as I told you, 1,15,200 is called baud rate. Baud rate means it is like how many number of bits is transmitted per second. Means in order to do all these projects, no, there is some speed limit. You can imagine you are driving a car or any vehicle on a road and you have a speed limit then and there. So why do you have a speed limit? To ensure that you are driving safely on the road. Just like that, all the electronic devices has this something called baud rate dears. So with the help of this baud rate, you will be able to know how fast the communication is happening. Okay, so the total number of bits transmitted per second is what you call it as baud rate. And for each and every controller, the baud rates are different. Okay, so you can see that for Raspberry Pi, it is 11520. Fine. So with this, I would like to wind up. If you have any doubts, you can ask now.
Thank you, ma'am, for this wonderful session. Uh, if you have any query, then you can ask question from our expert. You can post your question in the chat box or you can raise your hand. Ma'am, there is one question. How we can know
Yes.
for which controller baud rate?
Okay, I'll read to the chat box. Okay, how can we know for which controller what is the baud rate? Okay, that's a beautiful question, Shivaji. Listen, there's something called as data sheet. Whenever you're working on any controller, a data sheet is something which you will be getting along with the board, just like the specifications. So when you buy anything, no, you have something called specifications, expiry date, ingredients, and all present in water bottle or juice bottles, anything like that. In all the microcontroller boards, you have something called data sheet, which you will be getting either in the internet, and when you buy the board, you will get it along with it. So in that, the baud rate will be mentioned. Yes, surely I will be sharing the slide with ma'am and she will be giving it to you. Right. Ma'am, this code is written in Python or in Arduino. Okay, this code is being written in the Arduino language, dears. The reason why I chose Arduino is yesterday you learned Arduino, so I thought if I'm going to teach you in the Arduino, it will be easy for you. But you can also use Python in order to do this. Ma'am, I'll tell you how to do coding on Raspberry Pi, but how to upload the code? We can use in Arduino IDE. You cannot use in an Arduino IDE, dears. Yes, you can add an external battery setup for this. Can Arduino be used in the place of Raspberry Pi? So when compared to Raspberry Pi, or I mean, when compared to Arduino, Raspberry Pi is having a lot of things which you can do it. So you cannot use Arduino in the place of Raspberry Pi. Can we use the same code with Raspberry Pi 3? Yes, you can use it. Why we use pin mode in void setup? So pin mode is used whenever you want to declare it as an input and output. When you want to make any peripheral as an input and output, you can use the pin mode.
BSMIC school from Bulandshahr. You can ask question. You can unmute your mic.
Hello,
You can ask question.
I ask my question. Ma'am, I will tell you how to do coding on Raspberry Pi, but how to upload the code on Raspberry Pi and which platform to this upload this Raspberry Pi code.
Okay, so that's really a big question, dear. I can share you a PDF along with the slides to ma'am, okay? That will show you a step by step how to work on the hardware Raspberry Pi. So today what I have taught is all about the software part, but in hardware part, it takes a little time to dump the operating system. It's not that easy when just like your Arduino board. So I will be sharing the PDF of how to install the Raspbian OS in the Pi board, and then I will also share this PPT. Both will be helpful to you, dear, because it's a little big procedure which we need to work on. It's not like an Arduino board. In Arduino, you have an Arduino IDE platform. You simply dump the code in it. It's not like that here. Okay, so I will share a detailed PDF of it with ma'am. Any other doubts? What are the 4 innovative projects would you suggest for us by using the Raspberry Pi that are available in all the ATL labs? Okay, you can try out some IoT project, dears. So try first of all exploring with all the peripherals. Then decide what is the core problem statement which you want to work on. So for that problem statement, what are the input what are the output. Like that only you have to decide. Okay. Now I have seen some schools, they are working on smart dustbin. Okay. If that is the scenario, then you should decide for smart dustbin, what are the input, what are the output. In order to do this project, is Raspberry Pi really required or not? Okay, so that's the second important thing. Not all your projects require Raspberry Pi. Some can be done even with the Arduino controllers as well. So Raspberry Pi can be used in cases when your applications are little bigger. I want to do some kind of robotic projects. I want to do Internet of Things, machine learning. I want to implement some AI projects. Then Raspberry Pi is the best option. Okay, so how to make games using the Raspberry Pi? So I can, might be, if there is a possibility of one more session, I can explain some games, which you can develop. In the Tinkercad, you can develop very easily, but in Oakwee, it will take time. Might be in Tinkercad, I can show you how to develop games and publish it in the Play Store. Choosing the controller for the project. That's the beautiful question by a student. How to select the controller for the project. So it all depends upon the application only, dears. Okay. So for some application, I require a minimal level of work to be done. Arduino is better. I need a higher level of work to be done. Pi board. I need even more advanced level. Okay, I don't have enough battery with me, but I need to do some advanced work. STM32 is an excellent controller. So choosing the controller depending on the project is all dependent on what kind of applications you have. So just like that, we cannot tell, come on, for this project, you can use an STM. Try using a Raspberry Pi. Like that, just like that, we cannot tell. It all depends on the applications and what is really needed. So,
Ankit,
yes, ma'am, please go ahead.
Ankit sir wants to know the question. Sir, you
Yes,
can.
Ma'am, I have a question.
yes, sir.
Ma'am, is the AI was an external kit or kind of program we want to integrate in that chip?
Are you asking about AI, artificial intelligence?
Yes.
Okay, artificial intelligence is all about coding part here. Okay, it's not like an external kit. You can use AI for PyBoard, you can use AI for STM32. All these are hardware. In AI, we are going to make use of the software. So find a controller which supports that software.
Okay.
That's a beautiful question, Ankit. Can all the Raspberry Pi models support Arduino language like Raspberry Pi 3B? No, not all the Raspberry Pi supports it, dears. We are using Pico board. Pico board will support, but not all the boards will support. We need to understand this with the help of the datasheet only. Please use speaker to say hello in this project. Okay, see, the speaker what we are using in the Oakwee platform will not produce any sounds like hello like that. Okay, it will give you just a small beep sound only. So we cannot use a speaker platform in Oakwee to tell hello. That is not supported in Oakwee.
Parmeshwari Devi, you can ask your question. Parmeshwari Devi, the person who has joined from Parmeshwari Devi, I think it's the name of school. You can ask question. You can turn on your mic.
Yes, ma'am. Yes, ma'am. What is Raspberry Pi?
Sorry,
Yes,
please
what's the
go
question?
ahead. Dear.
Raspberry Pi.
Sorry?
Hello.
Yes, Kana, please tell me.
Hello. Yes, ma'am. Yes, ma'am.
You
What
are
is
asking okay. Ma'am, question is, it's a microprocessor.
what
Okay.
is Raspberry?
Yes, Sana. Please tell me. You are asking whether Raspberry Pi is a microprocessor. Is that your doubt, dear?
Yes, ma'am.
Okay, Raspberry, that's a fantastic question. So, Raspberry Pi is a tiny computer which has a processor inside it. Okay, it has ARM processor inside it. So, you cannot tell Pi board is a processor or Pi board is a controller. It is a computer which has a processor. Is it okay, dear?
Ajay Kumar ji, you can ask question.
What are the scope of Raspberry Pi?
Okay, fantastic. That's a very good question, Ajay. So, see, Raspberry Pi is being used in a real time. Okay, let's take a smart water bottles. Now, I'm currently in US and we have a lot of smart water bottles here, which will give you a message telling that you're not drinking enough water. Okay, we have a small Pico board present over there. So, lot of real-time products have Raspberry Pi in it. Okay, when you take an Arduino is very good for experimenting, but you don't have any product as such, that many products when compared to Raspberry Pi. You don't have a lot of products with Arduino, but you have a lot of products with Raspberry Pi in real time. So that's the beauty of Pi board. So to start with, you have to learn Arduino first, then you have to move to Raspberry Pi. Because when you start itself with Raspberry Pi, then you will start to hate electronics. So go learn Arduino well, then come to Pi board to make real-time product. Is it okay, dear? Can Raspberry Pi support the Wi-Fi and Bluetooth related projects? Yes, it can support. That's the beauty of using the Pi board. Yes, you need to put on the OS when you're using it in the hardware, but in the software part, in the Oakley platform, this is sufficient. How to choose the right project to use the Raspberry Pi because I want to use it in a right way and build an innovative project. Okay, so first of all, decide the problem statement. Learn to work on with Arduino boards, then start with a Pi board. In the Pi Pico board, try using in the Oakway your entire project. After that, you can get the components and try to implement it in the hardware. That's how you need to proceed on with bringing an innovative project. Please teach Arduino. Yes, I can help you out with that as well, dears. Okay. So, okay, so you are asking about the hardware part. Sure, dears, for hardware also, I will be I'll be sharing a document with ma'am. Okay.
One student is asking, can I use a Java language in this project?
Yes, you can use Java language, dears. As I have told you in the slide, you can use the Java, any languages in the Raspberry Pi and then you can do it. Java is bit complex, but if you are already comfortable working on Java, you can use it. Arduino baud rate is going to be 9600. You can just go to this menti.com, use this code and give your feedback here. In the meanwhile, I'll look into the comments for. Okay. What is the compiler for STM32? Very good. I'm happy that you're asking about it. STM32 Cube IDE. That's the compiler name for STM32. So for Arduino, it's Arduino IDE, right? Likewise, for STM32, it is going to be STM32 Cube IDE.
SVM Ramba, Goraksh Prant, you can ask question.
Ma'am, what is the future use of Raspberry Pi? Please tell me.
Okay. See, as I told you, Raspberry Pi can be inculcated more with AI. You can do a lot of IoT projects in Raspberry Pi. All the new technologies can be accommodated in the Pi board. That's the reason why we should learn Pi. Okay. When I say IoT or AI, software part we will be able to do it, but we need a hardware to dump it and visualize the output, right? So for that, you need a Pi board. Can you understand what I'm telling you, dear? You want two things. One is software, another one is hardware. Software means you are typing something. Okay. Hardware means you need a real-time products where you need to dump it. Now let's take a laptop. So in this laptop, what am I doing? I'm typing something. Correct. And I need a hardware device like a laptop. I need a keyboard. I need a mouse. Then only I will be able to see it. So that's the difference between hardware and a software. So in order to do AI projects or an IoT project, I need a Raspberry Pi board. Is it okay, dear?
SSVM, you can ask question. SSVM school, you can ask question.
How do you use Raspberry Pi in games and what kind of games we can create?
Okay. So games means, see, game is where you can deploy it in a board, right? Now let's take, I cannot tell like these are the types of games. Any game can be developed using the Tinkercad platform and you can dump it in a hardware. Okay, let's take I'm not very good in games, but I can tell you some car games which my son used to play. So some car games or might be roadblock games. You can develop any games in the Tinkercad platform. That platform is again at free of cost. We are not paying anything for it. When you have time, just go and explore the Tinkercad platform. You can bring just drag and drop, and you can build the games, and no, you can put it in the Play Store. If you really need a hardware, you can use a Pi board for it. And you are asking about the power supply of the Raspberry Pi. So Raspberry Pi needs at least the current capacity of 2.5 amperes. So that's a brilliant question. So 2.5 amperes is required. 5-volt power supply is needed. An ampere is 2.5. No, you can put it in the Play Store.
Gita Niketan
If you
Avasya
really need a
Vidyalaya, you
hardware,
can
you
ask
can use a
question.
Pi board for it.
Samsung.
Can I do ethical hacking? No, you can't do that kind of things in this, dear. You cannot do the hacking, dears.
Karan Singh, you can ask.
Ma'am, can we use Linux program in PyBoard?
Yes, you can use it, dear. You can use it, Karan. PyBoard will
Yes.
support Linux OS as well.
But ma'am, some codes are not supported in PyBoards. Linux code.
That's what it all we have to check to the data sheet there. So in some Pi boards in the older version, Linux are supported. In the advanced versions, I'm not sure. So we have to check to the data sheet only.
But ma'am, we have also a PyBoard 4 version,
Okay.
but it cannot support it.
Okay. That's what I will share with ma'am along with this presentation. A document where you can dump the operating system into the Raspberry Pi. Okay, that will
Okay, ma'am.
help you here. I will be sharing it by end of today or by end of tomorrow.
Okay, ma'am.
Remaining question you can ask. You can post your question, you can share your question with your ATL teacher, and we will answer the question on WhatsApp because time is short and we have to wind up the meeting. So thank you, ma'am,
Thank you, ma'am.
for this wonderful session. I hope the students learned a lot from this session. The session was really great and it was a detailed knowledge that you have shared about the Raspberry Pi. So tomorrow session was yesterday's session was about the Arduino, and
Okay.
today the students learn about the Raspberry Pi. I want to repeat the task which you have given to the students.
Yes,
So
I can
the
post in the
first,
chat box, ma'am, so that they will be.
okay. So the first task is regarding Arduino code for controlling a passive buzzer with Raspberry Pi. Second is button control LED with Raspberry Pi. So these are the two tasks given to you by the expert. I hope you will make project and complete this task before 15th April. Thank you, ma'am, for joining. Ma'am, we want to take the feedback.
Okay.
Then you can share the feedback details. I will share with the schools. So,
Okay, you're asking me? Okay, sure. Yes, ma'am.
schools will fill the feedback after the session.
Okay. No, do you want me to share any Google
Yes,
document
share
or
the, yes, you can share the details if you want to take the feedback of
Okay,
the
sure.
students.
Yes,
You can
ma'am.
share the
Yes, ma'am.
details.
Yes. Sure. Thank you, ma'am.
Thank you, ma'am. Thank you all. So we will wind up the session with Shanti Mantra. सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामया सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः स्वस्ति. All the participants, you can leave the meeting. Thank you.